So this one is from 2017 also, but in June 2017, June, paper 42, question number 8. So you start from phenol, and they're saying there's an amino acid tyrosine. Amino acid will do in amino acids is a compound that has both an acid and an amine. An acid and an amine and a phenol. So tyrosine's three functional groups are phenol, carboxylic acid, and amine. And you can make it from phenol. So phenol may you first add, they've added something with an alkyl group with a CHO towards the end. And then the CHO becomes hydroxynitrile. That looks like an AS reaction. Then CN to COOH, also an AS reaction. Then PCl5, also an AS reaction. Then Cl2 amine, AS and A2 reaction. That's it. So A2, the rest three are AS reactions. Now, also, and the mechanism for step number 1 is on the ring, electrophilic substitution. So for all these 5 reactions, let's come up with the mechanisms. Like step number 1 is electrophilic substitution. Step number 2 is nucleophilic addition. Step number 3 is just hydrolysis. Step number 4 is nucleophilic substitution. And step number 5 is nucleophilic substitution again. So electrophilic substitution, nucleophilic addition, hydrolysis. So that's the fun bit. That's why it says what are the mechanisms in 1 and 2, but what type of reaction is 3. So 1 and 2, the mechanism for 1 is electrophilic, substitution. That's basically, and the reagents and conditions for each of these reactions. Yeah. And step number 2 is nucleophilic addition. And step number 3 is type of reaction. Is CN to COOH was hydrolysis. Hydrolysis. So that's the type of reaction, step 1, 2, and 3. Now it's saying give me the conditions, reagent and conditions for all of these. So let's just put them all here, right? Step number 1, 2. Step number 1 may you're adding a CH2, CHO. So this is inconsequential, is a CH2 being replacing an H. So when a CH2 replaces an H, that must be a CH2 with a Cl. So CH2 with a Cl bonded to a CHO along with AlCl3, and for safety measure add heat. So reagent, condition, heat. Cl, so chloro, you can say 2-chloroethanol, but it's CH2, Cl, CH2, COOH. Now if you are concerned about drawing the skeletal formula for this fellow, that would have been CH2CO, like that. Cl on a CH2 with the CHO. That's this fellow. That's just added on. This guy is right here, and this fellow is this one. And then in step number 2, the CHO is becoming an hydroxynitrile. That's nucleophilic addition. And if you remember, you needed dilute HCN and NaCN aqueous. And the condition is heat under reflux. And step number 3 is CN to COOH. So you need any dilute acid. Let's say dilute HCl and heat under, in this case, heat bhi kafi hai, but heat under reflux is fine also. Why? Because this is such a large molecule, it won't vaporize really. So dilute HCl and heat is fine. And then step number, but you can write under reflux if you prefer. And in step number 5, right here, Cl2NH2. So the idea was that I was saying earlier that if you're going to go from a halogenoalkane to an amine, in AS you just needed ammonia and ethanol and heat. But in A2 you have to specify its heat under pressure or heat with high pressures. So heat under pressure. You got to create some pressure for this reaction. So instead of just heating, heat under pressure or in a sealed container. Like whatever container you use becomes sealed, so that when the gas is produced, it stays in the container and then it increases pressure. So this reaction is ammonia and ethanol vaporizes very easily, so you maintain a high pressure to maintain that reaction. And this, by the way, if you want to know what reaction 5's mechanism is nucleophilic substitution. Haloalkane to amine. All right. So that's the first part of this question. Now on the next page, the question was about reacting with NaOH, HCl, and bromine. So instead of putting the question here, I'm going to put the molecule 3 times, because it's this guy that they want to react with. The first one is with NaOH, aqueous. So what we didn't are draw the structure of the products of the reactants of tyrosine with an excess of each of these reactants. So it's NaOH aqueous in excess, and then HCl aqueous in excess, and bromine aqueous in excess. So again, and it's not heating, so it's just NaOH is an alkali, it will neutralize the acids. HCl is an acid, it will neutralize the alkalis. And Br2 will just react with the phenol group. So what would NaOH do to this molecule? It will react with the acid. This is the acid, this is the acid. So what happens to the acids? The acids become salts. So the H is removed. So I'm going to remove the H. And the H is removed. And they both become negative ions. Literally, you want to add an Na if you prefer. I don't like to, but fine. If people insist, then this is where the Na would go. But I want to insist on putting the charges, though I do not care about sodium. So even if you want Na, you can put it. I will never put it. I like my ions. So I'll just make it COO minus. All right. And it's an ion. Even if you put Na, you have to show the charges. Now what does HCl do? So this is what NaOH did to the molecule. So what would HCl do to this molecule? Acid, and this is the only base there is. So what happens to NH2? It becomes NH3 plus. You want to put a Cl minus? That's go ahead, that's fine. But it becomes NH3 plus. And Br2 aqueous will react with the phenol group. And with the phenol group, it'll go on positions 2, 4, and 6. So 2, 4, and 6. But there's already something at 4. So it'll go on only positions 2 and 6 with aqueous bromine. So these are the organic products. The inorganic products we don't care about. All right.